And we have our goal. Okay, wonderful. So, we had a nice big long discussion the other day about strings and immutability. But the key takeaway from that, unlike most objects, if you change a string, it actually creates an entirely new string object. Okay, that's the key takeaway. So, this we'll recap because we covered it a bit last time. So, indexing for strings, each string contains an array of type char, basically a sequence of characters. Minimum length of a string is 0, so you can have an empty string, and if you want to declare a string as an empty string, you can simply do this. Fun with strings, let's make a different one. If you want to declare an empty string, you can just do this. String s equals, and two pairs of quotes, right? One pair of quotes right next to each other. And then if I print it out, system.out. I give a second because of the lag. Yeah, codex ball. Okay. If I print out s, it prints out nothing. Right? I actually print out the zero length string of nothing. So, it's not null. Zero length is not the same as null. And I'll tell you why in just a second. So, the s, right, the string s is between the two periods. So if I run this, I have two periods right next to each other. Now I'll note this. First of all, an empty zero length string is not null. That's a good question. Okay? If, for example, I say string t equals null, if I literally say this is a null string, and then I print out t, what happens? Well, wait and see. It's kind of crazy. It actually prints out the word null. So that's kind of weird, but that's what it does. Zero length string is simply a string with a zero length character array. It doesn't have anything to print. A null string has not yet been created. Okay? It has been created and has a zero length char array. Okay? A null string has not been created and doesn't even have a char array. And I'll prove that to you. So, string has a method called length. Okay? Which we'll cover some of these string methods. String has a length method that returns the number, well, the size of the char array, which means the number of characters in the string, right? How long it is. So if I do this, if I say system.out println s.length equals plus s dot okay, that'll print out what? How long is s? 0. I mean, the answer is right there. It is a zero length string. It has zero length. It has no characters. If I run this, okay, s.length is 0. Now, if I try to do the same thing, with t, what's going to happen? Worse. It's going to be much worse. Remember, t doesn't even have a char array. And there's something that happens in Java called a null pointer exception, where basically the program crashes when you try to read an attribute of a null object. If I haven't created the object yet, it doesn't yet have the char array, thus there's nothing in that object to read. Right? I don't even have a reference for that attribute of the object. So s.length is going to go fine, t.length is going to make it crash. Boom, exception in thread main, java.lang.null pointer exception. At this line, that's what you get, okay? You're trying to read an attribute of an object that hasn't been created yet. Okay. Since t is null, it has no char array to get the length from, and so causes a null pointer exception, and the program crashes. Okay, so that is an important distinction, right? Strings can be zero length, which is totally fine, right? They can be some other length and have a number, that's fine too. But if it is a null string doesn't have a length. Null string hasn't been created yet, there's nothing there to read. Okay. So, like I said last time we covered this slide, I'm recapping. Upper bound is really big. In theory, you can have a string up to about 2 billion characters, but for a lot of applications, things are going to go wrong way before that. And in any array, indexing starts at 0. So the index of the first character in a string is 0, and if there are many characters, the last, string of n characters long, the last available index is n minus 1. So if you have a literal string hello, capital H is index 0, lowercase e is index 1, the two L's are indexes 2 and 3, the last index is 4. It's 5 characters long, but the last available index is 5 minus 1 equals 4. Okay, that's how indexing works. Now, that's a recap, so I'm going to zip through it. String is a complicated class. There are many methods for string. If you want to check them out, you can. There's a lot of useful ones. Or you could do this. If you could just create some kind of string in here, and you could just scroll through all the options. For example, I could do this. I could do word dot. And once I hit my dot brings up this auto help method. So I'm saying for this literal string word, dot, what things can I get from it? There's a lot of methods here. Okay, there's stuff char at or chars or compare to or concat or contains or equals ignore case or blah 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 blah. A lot of stuff. Okay, we're not going to cover all them. If we covered every method of every object we went through, we'd lose a lot of time. So I'm going to cover perhaps the most important ones. So char at, length, index of, substring, and starts with and ends with. So, first one's easy. Char at. Char at requests the character from a string at some particular index. The argument, when you call it, you send an int as the argument. So you want to say, I want to read the character at index x. You send along index at the argument. Okay? And this method returns a character. So, you can do this. We're going to zero this out for a minute. Well, let's do our other stuff first, and that'll be okay. So we're going to do fun with strings 2, FWS2 is new, fun with strings. Okay, and then FWS2 dot, we'll call a char at demo method. Okay, so let's make that. Do a char at demo method. So void char at demo. So in this, we're going to have a string. Okay, we're going to have a string s equals, give me a word. What? Time. All right. Okay. And system.out.println character, give me an index between 0 and 3. 2. Okay. Character 2 of s is plus s dot char at 2. Okay. So this is the method we're going to run. S is going to be time, and then we're going to print out this message. Character 2 of s is s dot char at 2. So we'll say the character at index 2 of s is this. But but the second character of S is too many? Thought I did. Okay? So, if I want the second character, remember the first index is 0, so the second index must be 1. Okay? Character index 2 is going to be M, but the second character of S will be lowercase I. So we run this. Where did I have an error? You bastard. You're at demo. Oh, phone strings 2. Okay. So let's run it. Okay. Second character at index 2 is M. Second character of S is I. We can even, let's replace that. Okay. So that's good. So let's run this. Second character index 2 of time is M. Second character of time is I. Okay? So that's what char does. Char pulls a character from a particular index of a string. And it's obviously useful if, for example, you're doing some kind of text search and you want to say, you know, show me all the time that this word appears. Well, you start by matching the first character of that word to the Java string object. Yeah.
What was your error on
when I run it?
No, when you labeled the variable. Remember before you ran it, you had an error on the variable. Yeah. What was
This? Oh, I just had the wrong class name up here. I had it fun with strings instead of fun with strings 2. So if I do that, then whoop, something that's what it was actually. Anyway, it should be fun with strings 2. Yeah. No, index 0 is the first index. So I'm not asking for the first one, right? The first character of S is at index 0, so I can add in an extra line. That's great. But, and, I'll do an and here. Okay? The first character is at index 0. Indexing starts at 0. T is at index 0. Yes. Starts from 0. Yep. Okay? All right. So, Carrot, if you know, and it's always a very popular thing. I mean, hopefully, you know, you guys don't miss it, but there's a lot of empty seats, and those people, well, I don't know what's going to happen to them. But all right. So don't miss that. But again, it's like the math stuff. It's one of those things that it's easy if you're slow and you take your time or whatever, but people panic and they, you know, stuff goes off the rails. Okay. All right. Second one, length, which we've already seen. So length requests the number of characters in the string. Arguments and returns, you don't have to send along an argument because the string only has one character array, so you know which thing you're going to read, and it returns an int, right? The length of the array. So, for example, if you have a string s that equals hello, calling s.length would return 5. There's 5 characters in hello, s.length will return 5. So we'll do that in our thing. So, void length demo. Give me another word. Give me a longer word. Dragon Ball Z. That is acceptable. I'm just going to run it all together. Okay? How many letters? How many characters? Yes. There are s.length characters in okay. So however many characters there are, that's going to be represented by s.length, which would be 11. Okay, there are 11 characters in that. So we run it. Oh, I didn't call the method. That would help if I called the method. Okay, let's run that. There are 11 characters in Dragon Ball Z. Okay? Notice, that's not the same as the last index. Note that the last index of Dragon Ball Z is actually 10, not 11. So do a system.print line. The last index of S is actually -1. Okay? Last index of that here. I'm going to kill this window so I get a little more space. Okay. Last index of S is actually this, S dot length -1, which holds, just to prove it, which holds character plus S dot char at, same thing, S dot length -1, which of course is capital Z. Okay, so let's run this. Why am I still getting errors? Extra parenthesis. 11 characters in Dragon Ball Z. Last index of Dragon Ball Z is actually 10, which of course holds the character Z. Yes? Index is not a reserved word. What, you mean just the word index in context of an array? Okay, let me explain. So, we'll do this. Okay. So suppose I have this string Dragon Ball Z, okay, and I'm just going to kind of need two. Let's slide that over just a little bit. Okay. Okay. Now each of these boxes, right, it's grouped together in the string. The string holds this array of characters, and basically it looks like this. So in the first memory location, it has a D. The second memory location has the R, and so on. Okay, so they're stored sequentially in the array. Every one of those indexes has a value, has an index number. So the first index is 1, and so on. Oops. Okay. Every one of those boxes of the array has an index number. Okay? So, if I want to say ask char at this index, I would say, call the method, yeah, so let's say string s equals this, right? So I'll say s dot char at 0 will return the character D. S dot char at 9, let's do 7 since, let's do 6, will return capital B. Okay? That's just how the indexing works. And I don't know, I mean, arrays in general, Java use this kind of scheme where it starts at 0 and counts up. Okay? But it's all sequential for a string. So whatever order the letters are added in, right? Like here, time TIME, right? They're stored in that same in the sequence in the array. The first index 0 is T, second index has lowercase I, and so on. Okay. A few more methods. Okay. Index of. Index of is very simple. Request the index of the first occurrence of some character or string within a string. Okay? So, optionally, you can include a starting index if you don't want to include the whole string, but we're just going to say if you're looking for something in particular and in the entire string. And it'll either return the index where the text was found, where it starts, which could be 0 or any positive number, and it returns a -1 if you don't find it. So -1 is kind of the default for saying it isn't in this string, because a string can never have a negative index. Index counting starts from 0. So, for example, do this one, void index of demo. Give me a string, give me a word, a long word, give me a sentence. All right, fine. String, one hot dog fell down the drain, but I fished it out and gave it to you. Disgusting. All right. System.out dot print line. Where does the word hot dog, where does the string hot dog appear in this? What index does it start at?
Is a space counted?
Is a space a character?
No.
Space is a character.
Okay.
Correct. Index 0, index 1, index 2, index 3 for the space, index 4 for H. Right? So, hot dog is found at index okay? So if I run this, I'm going to call index of demo. Hot dog is found at index 4. Okay? Easy. Now what's something that doesn't appear in here? Right, well, slice of bologna appears at index what? I just do bologna. It's gonna zoom at index of bologna. Is bologna appear in this sentence? No. Let me do this, system.out.println. In the sentence, okay. Bologna will appear at index -1. It doesn't appear. Or what? Oh, print. No, let me do print line. That was some auto-correct thing. I must have hit a wrong key and something. Print line just means the text will appear on a new line. If I just do print, it all runs together and it, kind of blah. So, all right? So, in the sentence, one hot dog fell down the drain, blah, blah, blah. Hot dog is found at index 4. Bologna appears at index -1, right? It doesn't appear in the sentence. So that method call returns a -1. Yeah? Okay. -1 means don't find, it's not a valid index, so I mean that's what Java uses to say I didn't find this thing. Yeah. Okay. A couple more and then we just have some simple stuff. So, substring. Yes.
For example, if B is a character in the sentence, and we ask for, try to find the index of B, and there are two B's in sentence, is it going to give me the first one only, or is it going to
It'll give you the first one.
first one?
Yeah, and reason is index of returns an int, so it can only return one number. It can't return two separate ints, it only returns one int. Okay, so if I, for example, ask for the letter N, there are many N's, right? We could do that. N is found at index Mix of. I can do a character here for that because it's just one. Okay. And it's found at index 1, right? It's right there. So I get the first one. Yep. Okay, good. All right. So substring is a tricky one. Substring will mess people up. So what the substring method does, it requests some indexed portion of a string. So basically, you give Java one number to start, one number to finish. Between those two is the substring. So you have to send two int arguments. The first one represents the index included, and the second number indicates the first index that you don't include, which is a screwy way to do it. If they had asked me how to do the syntax on this, this is what I would have done. I would have said the first number is the index where you start, and the second number is how many characters you want to retrieve. That's what I would do. In fact, you can get that because for any number pair, this minus that is how many characters are retrieved. So if I start at 0, I include 0, I include 1, I include 2, but I don't include 3. I'm getting 3 things. 3 minus 0 is 3. If I start at 2, I include 2, I include 3, but I don't include 4, I'm getting 4 minus 2 equals 2 things. Okay, so the substring length is the difference between the arguments. So if you want to get 5 characters starting at index 0, you do 0, 5. If you want to get 20 characters starting at index 10, you get substring 10, 30. Okay? All right. So we're going to do a substring example. I mean, there's one right here. So first 3 characters of hello, 0, 3, HEL. Method call s.substring 2, 4. Give me 2 characters. Starting at index 2, give me 4 minus 2 equals 2 characters. So it returns the double L. And if I call the substring 0, 0, it returns a 0 length string. And in that case, it doesn't matter where I start, right? I can start at 1, 1, 2, 2, 3, 3, whatever. It's always going to return a 0 length string, which will have no contents. Okay. Let's give an example in the code. Oh, that's what that thing is. I knew I typed one in. Okay. Okay. So string S equals the quick brown fox jumped over the lazy dog. Okay. Substring, give me 2 numbers. What's that? 20 and? Okay, I'll start at 6 and go to 20. Okay, so string T equals S dot substring 6, 20. So starting at index 6, return 20 minus 6 equals 14 characters. Okay? So system.out.println for the string the substring I'll say its substring okay. So we'll call that method and we'll run it. What should we get? What's index 6 start at? Well, this should start at, is that I for 6? I believe so. And so it'll return 14 characters starting with I. So ick brown, that's 9, 13, ick brown fox. Okay? That's what it should return if I've done the math correctly. Okay. its substring is ick, brown, fox. And notice I do have that space character there. Okay, that's all that exists on that. Well, I threw in an extra one at the end, but still. Okay, ick, brown, fox. Okay, 4 characters, 5 characters, 5 characters, get 14. Okay? Substring makes sense? Hopefully. Okay, so again, if you get a thing on a quiz or on an exam, give me the first 6 characters of string s dot substring 0, 6, right? Starting at index 0, bring back 6 minus 0 characters. Okay. Starts with and ends with. Those are real easy. Those don't require a lot of explanation. So it just checks whether a string starts or ends with another string. Okay, so this returns a Boolean variable, either true or false. So if we have string s is hello, and I want to check is s starts with he, well, hello starts with he, that will return true. Method called s dot ends with he returns false. All right, doesn't end with that. Those aren't the last 2 characters. All right, we're a little low on time, so I'm going to skip on over. Let's see, we have a few things. All right, good. So we're right on time. We have some knowledge checks and we have some extra things, but okay. Concatenation. We've seen this. Okay, now you get the full whatever on. So normally the plus symbol indicates addition. If you're talking about numbers, plus means addition. However, if there's a string involved, it means concatenation, which is, again, fancy word for running stuff together. So that means the second string gets appended to the first. So 6 plus 6 is 12, but string 6 plus string 6 is string 6, 6, right? It gets run together. This string 6 is not the same as a number 6. This is an object, a string object that happens to have in its char array 1 character corresponding to the text value 6. Okay. Now, concatenation still happens if either side of the addition is a string. So string plus 5 or 5 plus string 5 both concatenate to string 5, 5. In a sense, this is exactly like promotion. It's as if string is a different type that outranks all numeric types, and anytime there's a string involved in an addition, right, both things are converted to a string and brought together. Okay? Yeah, yes?
If I write, within quotes 5 and then I write int 5, it will give me an error.
If you write what?
Like 5 the way it is, 5 within the quotes, and the plus 5, like I write plus int 5. If I
Typecast it?
Yeah.
You can't typecast a string to an int.
So it will give me an error, it won't run, right?
Yeah, it won't compile. Yeah. So we'll demo that. We can do that right now. So string s, if I just do this. Yeah, it doesn't make sense. You can't convert a string to a number. However, right? I mean, you can't convert it through typecasting. But we're not done yet. Okay, so first thing is this. Okay. The addition operator still follows the order of operations, right? So it's as if string is the supreme numeric type. So if we have 3 plus 4 times 5, that's 23, right? We do the multiplication first, then add 3 to it. 4 plus 5 times 4 times 5 is 20, add 3 for 23. However, string 3 plus 4 times 5, do the multiplication first, get 20, and then this is a string. It's string 3 concatenated with 20, we get 320 string. Okay? Different, but still follows the order of operations. Now, if you want to convert primitives to strings or vice versa, there's ways to do it. So, if you want to convert a string to a number, if you have a string that is all numeric text and would be a valid number, you can call this integer.parseInt to turn a string into an integer, and you can do double.parseDouble to convert a string into a double. That'll work, okay? As long as, the string actually, in case of int, as long as the string represents a valid integer value. So like string 66, you could convert to an integer, but string 66.3, you couldn't, right? It would be demotion. All right, and for all the other types, there are also similar things. So there's byte.parseByte and float.parseFloat and so on. So for any numeric type you want to use, it basically follows the same format as double. Integer is weird. It doesn't start with int. It starts with integer. Anyway, to convert numbers to strings, easiest way is to use concatenation. If you have a number 9.3, but you want to create a string object that has the text 9.3, just do concatenation. String s equals empty string plus x. It's going to concatenate to string 9.3. Yes?
There will be a space though when you print it, right?
No. Why would there be a space? Empty string has what length? Space has what length? Yeah, no space. Yep. This is perfectly safe. Okay. So quick knowledge checks, and then I guess we'll come back next week and wrap up these little oddball things at the end. You can look at them if you want. I mean, they're already in here, like system.out.print, scanner. I've covered them over in the lectures, but I'm actually, referencing them here. And this we've done as well. Okay, knowledge checks though. Number one, what's the difference between a character and a single character string? Fundamentally, a character is a number. A string is an object. It is not a simple primitive. So a lot of things you can do with a character. You can do multiplication, you can do numeric addition. Can't do that with a string. However, if you print them both to the console, they're going to print the same. Okay? So char is a number that prints as an integer. Second thing, char and short. They're both 16-bit numeric primitives. How are they the same? Other than being 16 bits? How are char and short the same?
One has symbols.
Well, not directly. They're both the same in that they're both numbers. Yeah, you can do multiplication, division, all your standard numerical operations on them. What's different? Number one, if you print out a short, it prints out as a number. A short is a regular number, prints as a number. You print out a char, prints as a text character. Second thing, short is signed. It can be positive, it can be negative. There's a sign. Char is unsigned. It's char is 0 to 65,535, right? 2 to the 16 minus 1. Short goes from negative 2 to the 15th to 2 to the 15th minus 1. So minus 32,000 and change to plus 32,000 and change, right? So they can't hold all the same values that the other is, so you can't typecast one easily to the other, right? I mean, you have to explicitly typecast. You can't just say short equals, character M. And you can't say char equals necessarily any value of a short, because a short could have a negative value. Okay. Last stuff, string creation, literals versus new objects. Remember, if you use new when you're creating a string, you actually create a new separate string object in memory. If you create a string using a literal, you say s equals inside quotes string word, whatever, then any other object that use any other string that is similarly created with that literal will share that one reference. It doesn't create a new thing in memory. Okay, and we talked about that. There's immutability as well as involved there. And those string methods that we covered. So exams, quizzes, they will give things like, here's a string, what's the result of calling this method? Like you have a string Mississippi, what's char at 6? Or what's index of is? Or what's substring 4, 8? Things like that. Okay? All right. That's all I got for you then. Let me do a last check, because making sure we don't have a quiz on Monday, we might. Seems like the sort of dick move I would do. Let's see. Yeah. Quiz 2 is next Wednesday, so we'll do some practice in class on Monday, in addition to our other stuff. Okay.